Usually passive and active. Passive means, what do you mean by passive device? What do you mean by active device? Yes. Are you active or passive? Are you active devices or passive devices? Active, yes. Yes. So which will give energy or which will do some changes. So which have some energy storage, we call it as generally active devices. So like capacitors, they store energy. Like a battery, cells, they are active devices. Whereas a resistor, passive. It has nothing to do with energy. If you give, he will take. It won't do anything. So such devices are called passive devices. So they are passive devices. If you touch also, there is no problem. Basically, active devices, we should be careful. For example, if there is a capacitor like that, don't try to touch. If the capacitor is charged and already some energy is there, if you touch, so there will be a current and something can happen. So we should never try to touch active devices without prior knowledge and precautions. So passive devices, it doesn't bother. So resistors are passive devices, and basically, so industry has been standardized. So there are something I don't want to go basically about these things. Then if a small resistors, I kept a resistors on the table. So how to identify the resistance of a resistor? So that's what we will go in this experiment. Yes, multimeter से ही करेंगे, but I don't want multimeter से, but you should. So there are some color bands on these things. If you see, we use popularly 4-band resistors. So, hey, there is no mouse on that. आ रहा है. Yes. Okay. So basically, these type of resistors are popularly used. We call these as 4-band resistors. If you see, this is a resistor, it will have 2 leads to connect, and these are 3 bands are one side, and the 4th band will be on the other side. So sometime 3-band resistors also will be used. So the 4th band will be missing. So what these 4 bands, how to read them? So basically, we use a color coding to read the value of the resistance. So this is the thing which usually electronics people will remember, like tables in mathematics. For electronics, we remember these values. So what these colors mean? Every color has a number. So basically, if you see these things, so the numbers are from 0 to 9 we have. So 0 to 9 we will have some color. So very common, 0 means no color, black. The highest number means all colors, something like that, white color. And afterwards, if you see the popular colors, we remember like VIBGR. So how many colors are there in VIBGR? That 7 we use it. But if you see that indigo, violet, blue, they will be very close. So that's why one color we drop here. That indigo is dropped here. So effectively 6, black and white. Okay, so 8, another 2 we want, 10 digits, no? 0 to 9 are 10 digits. We want 2 more colors. So that's why we introduce 2 colors called brown and grey. So ब्लैक के साथ ग्रे नहीं बिठाया क्योंकि दे विल बी वेरी क्लोज. सो दैट्स वाई ब्राउन को बिठा दिया, और वाइट के साथ ग्रे, और इन बिटवीन द अदर कलर्स यू कैन सी वायलेट, इंडिगो is skipped, blue, green, yellow, orange, red. Actually, people remember something like BB Roy, something they will have an acronym, but usually we don't require anything. If you know what is the logic, how they are kept. So black and white, brown and grey, and violet to red, the indigo is skipped. So if you see really these days, if you see a rainbow, how many colors do you see? Can you see 6 colors in a rainbow? Hardly 4 colors, 5 colors. Okay, ancient people, they have very good vision. Their eyes are very perfect. They can see 7 colors. So they named 7 colors. So if a rainbow has to be defined today, we will define only with 4 colors. Okay. In this rainbow contest, I will ask a question. How many colors are there in a rainbow? I don't think you remembered my earlier question. How many colors can you see in a rainbow? How many colors can you see in a rainbow? How many colors are there in a rainbow? Are both same or different? Different. There may be many things, but what you can see are different. So that's why you should. So if such questions come, no, you should be little bit careful. Yes. Oh, paper there. Yes, isn't it? How many colors are there in a rainbow? How many colors are there in white light? 7. How many? Okay, so that is a basic difference. There are infinite or many colors or many wavelengths. Okay, before that, since a color word came, what do you mean by the word color? What do you mean by red color? What do you mean by yellow color? What do you mean by blue color?
Substance absorbs all other wavelengths and reflects the wavelength of that wave at particular.
So,
That is what our eyes see.
yes, you are very perfect. So, in one, I will conclude his things. Color is a name of a wavelength which our eyes can perceive. Okay? So, I am seeing a wave coming from his t-shirt as something different. So, I can't call, 5800 angstrom is coming from you. It will be very good. I can't say 4200 angstrom is good on you. So ऐसे ही फिजिक्स वालों को पागल जैसे देखते if I use such a terms, no, then so for common language we put an English word for wavelength. Okay, so 7000 angstroms are good on the sofa cushions. No, a red color is good on the sofa. So color is nothing but an English name given for particular wavelengths which our eyes can perceive. That's all. Okay, so that is the meaning. So yes, here. So if you can perceive most of the colors simultaneously, then what is white color? Yes. So combination of many colors or many waves, so it gives another feeling which we call it as white color. And what do you mean by black color? Yes. See, we are very good in naming nothing also. Indians are very good in naming nothing. In mathematics, if there is nothing, we put a 0. In reality, if there is nothing, we call it as vacuum. Shunyakash. In Indian mythology, we have name for nothing. That is a very good thing. So in here also, in colors also, if there is nothing, we call it as black. So if I am seeing something black means what does it mean? From there no waves are coming. So that is something like a gap or vacancy. So my brain processed that thing and I kept a name for that also as a black. So that's all. White means many things coming simultaneously. So they give combination of many waves, give one common impression, and I called it as white. So if I can separate them, I will have many colors. Okay, so that is the reason. So that's why we use these things. So now you can remember this very easily. Black and white, brown and grey, violet to red without indigo. So 10 names we got it. So if there is a black color anywhere means its meaning is 0. So if there is a brown color means its value is 1. So like that. Okay. Now let us see this 4 band. There is a gray color here. So gray color means 8. So yes. So the first two fellows, the first two bands are two digits of a number. So first one is 8. See what is gray? Here gray color is there in this example. So gray means 8. And afterwards there is a red color. Red color means 2. So it is 82. Next, what is the third fellow? Third fellow is orange. Actually third band is a multiplier. Matlab this is first band, second band, 2 digits into 10 to the power. third band. So this is 82 into 10 to the power of whatever this band. So this is C. So 82 into 10 to the power of 3, 10 power 3 is kilo. So that's why they have written kilo. And what is this fourth band? You know, in reality, nothing is perfect. So they prepared this, but exactly will it be 82 into 10 power 3 ohm? So no, in manufacturing, so they make some small plus or minus things. How much error can you expect? So the precision, they say 5%. So here, so if you see a gold band, it means it is 5%. Okay. So if you see silver band, it is basically 10%. If you don't see any band, like here, it is 20%. So you can expect a 20% error, don't complain them. So plus or minus 20% of this value, you should accept it. So if in a circuit, if you can allow the 20% margin, then only you use it. If you can't tolerate the 20% difference, then please don't go for it. And definitely the complexity and money involved in preparing things goes on if you want more accuracy. Because the material, the length of the things, whatever they use in preparing things, they should be very precise. So that's why definitely if you go for 5%, 10%, and there is another fellow also, 1% also will be there. So which we don't use. Basically 1% people they use in the satellites and very, very complex, very critical circuits, they use 1%. 1% means very less margin you are giving. So that they will be very costly. So let me tell you, if 20% is 1 rupee, 10% will be 100 rupees, 5% will be 500 rupees, and 1% will be 10,000 rupees. So like that the rates will go, because the things will complex in manufacturing the things. So usually we go for 20%, 5%, 10% we skip. If you want, you use 5%. If you not, you go for 20%. We don't want to maintain three types of resistors in our circuit. Generally we maintain two types, casual and little serious. Okay. So if you see three bands only one side, so you can directly say plus or minus 20%. So on these tables I have some resistors I collected from electronics lab, and I want 3 or 4 different types of 3 different value resistors you find out. By color coding you find out the resistance and write, and using a multimeter measure the resistance, and you check whether the fellow is coming in that range or not. So that is plus or minus 20%, plus or minus 5%, those things are there, no? Literally if you measure, you won't get this value as 82 into 10 power 3, you will never get. Something less or more you will get. See whether it is a gold band is there, the value is within 5%. You please check it, okay? Yes, so that is part A of these things. Another thing is series parallel combination. So in the market only these resistors are available. If you want some other resistance, what you will do? Only 82 into 10 power 3 ohm is available. After this, there is something like 128 into 10 power 3, something like that. They don't have all ranges. They will have some discrete value resistors. So if you want some other resistance, what you will do? You have to do some connections such that the effective resistance is whatever you want. So popular two types of combinations we know is basics is series connection and. So you take two different resistors, do a series combination, and already you have the values individually. Using those values you can calculate what is the series, what is the parallel, and using multimeter you calculate what is the series, what is the parallel. So these things, okay. So you will get an idea in a series combination what happens for resistance. See, if you take a length like this, length increased, so resistance increases. So typically if you join series resistances increase. If you join parallel, you are increasing the area, something like that. So the resistance drops. So for parallel combination, resistance drops. For series combination, resistance increases. So one result is, in a series resistance, the total resistance is more than the greatest value.
And in parallel,
It is the lower than the lowest. Lower than the, for example, if you have 1 ohm, 2 ohm, 5. For example, if there are some 5 ohm, 5 ohm, 10 ohm, 20 ohm. If somebody say I want 1 ohm, what you will do? You will put a 2 ohm or something parallel. definitely the total resistance will be less than 2 ohm. See, whenever you have something 82 kilo ohm, I say I want a 10 kilo ohm. So immediately what you will do, you will search something close to 10 kilo ohm and you will put it in parallel. So definitely the parallel combination will be less than the lowest. So definitely you will come closer to that. So like that you should do. So in reality we do like that only. So this result you should remember when you are doing series and parallel. Just it is not mathematics. R is equal to R1 plus R2 like that. 1 by R is equal to 1 by R1. So this is what we should remember in the result. So in your MCQs entrance exams also you should never do it. For example, if 1 ohm, 2 ohm, 3 ohm, 8 ohm resistors are connected in parallel, what is the effective resistance? You just see the option. Whoever is less than 1 ohm, that fellow. Okay, by mistake, if there are two values less than 1, then you should try. But mostly they won't give like that. Only one value will be less than 1 ohm. So the examiner don't want to calculate. That fellow want to check based on your practice whether you concluded the result or not. So because in the in entrance exam 1 minute you have to read the problem and do. So more than 50% problems you need not do. Just by seeing the 4 options you can click it. So this is the conclusion which you should get. Okay. So this is the experiment. I think Pritesh, breakfast हुआ? Alright. We will take a breakfast break. I think everybody went means. Let us take a breakfast break and come back and do it. Okay. This color coding sheet is there in your booklet. You just refer while you are doing this. You need not by heart. And it will be on the screen also. I will put it on the screen if you want to see. एक्चुअली 4 बैंड एक्चुअली हाँ एक्चुअली ये जनरली इंटरनेट से उठाया इसमें सभी बैंड्स वाला रेसिस्टर्स के लिए है बट पॉपुलरली वी यूज दैट्स व्हाई आई राउंडेड इन हियर आपको प्रिंट करने के बाद मैंने सो वी यूज दिस 4 बैंड थिंग्स ओके यू वी विल फॉलो दिस 4 बैंड if you somewhere if you see a 5 bands or 6 bands then accordingly like this. So actually it will be actually there are 4 bands here. So it is a 3 digit like here 82 into this. So this will be 3.21 into the something. So the things will be so if you have very higher ohms, so then we go for other color codings. But usually we don't go for that. We use a 4 band. Temp. Per Kelvin basically. That is temperature dependency also they have mentioned.
May I add something?
Yes.
Actually, this 4 band or 3 band. So there are multiple types of
Resistors.
like carbon film, then
Metal film.
So tolerance is very important.
Yes.
Carbon film tolerance is very less.
Less.
Those are cheap.
Cheap.
And if you are going for this fighting higher bands, then their stability, tolerance,
Yes.
then that is mentioned.
That's what I said.
So those are more accurate and more reliable.
Yes. So you go for more accurate things 1%. If you see 5 band and 6 band, they are about 1% fellows. 1% means tolerance is very crucial and they are very things. But usually we go for 3 band and 4 band for most of the things. Where the things are not very crucial, we have a margin. So that is the basic difference. Join for the breakfast. वो ये रेसिस्टेंस वाला करेंगे मैंने रख दिए टेबल्स पर तो समझा दिया दे विल डू इट इसलिए ब्रेकफास्ट आप हो गए आपका ओके प्रीतेश ब्रेकफास्ट चले इसको ना पड़ेगा
नहीं कर देता हूँ।
We will wrap up this experiment in 5 more minutes. Students, we have 2 more big experiments actually. Actually, these experiments are big according to me. Yeah. Students, let's go for a next experiment. You can do calculations later. Please be seated. Yeah. Okay. उसका वॉल्यूम बंद. Okay, please sit. Actually, this will be an interesting topic actually. Till now we have seen electricity and resistance and whatever related to current electricity. But do electricity has any interesting angle with it? We know magnetism is there already. We see permanent magnets. So-called that magnet materials or objects will exhibit magnetic material, magnetic properties, attracting iron, ferrous materials. So can anyone say what is the unit of magnetic field? Yeah, very good. So what is the smaller unit of magnetic field? Gauss. Do you know what is how many Gauss 1 Tesla? 10 raised to 4. Tesla is big. 10 raised to 4 means 10,000. Okay. So 10,000 means it will be very good to understand. 10 power 4 means we can't feel it. So 1 Tesla is 10,000 Gauss. So you remember most of the bigger units we divide into 1,000 pieces. But 1 Tesla is divided into 10,000 pieces. So that's what yesterday I said, in the 12th class units they are very bigger units. So that's why we made it into 10,000 pieces to get a reasonable piece. So do you know that Earth acts like a magnet? Earth has magnetic field and it stops, it controls the solar particles coming from the sun. Yes. You also know some small magnets you played, जो black color magnets. So जो सोवनिर्स में फ्रिज या अलमीरा को चिपकाते हम कहीं जाकर आए तो. So you know 2-3 examples. Earth is a magnet, those small magnets. So do you know what is the magnetic field of Earth? Earth का magnetic field value 10 Tesla, 1 Tesla, 1 Gauss, 0.1 Gauss. कितना होगा? Earth stops these solar particles at 70 to 80 kilometers only. It will stop. That only we call ionosphere. So it stops at 70 to 80 kilometers. It stops. So the magnetic field of the Earth is very high or low. Do you know magnetic field of anything? Those magnets जो फ्रिज के ऊपर चिपकाते पीछे black color का राउंड कलर में होता है। हाँ, एमआरआई का कुछ, ओके गुड, एमआरआई का मैग्नेटिक फील्ड पता है इसको। एमआरआई जो कराते हैं उसमें भी दे यूज मैग्नेट्स, सो उसका मैग्नेटिक फील्ड समथिंग लाइक 1.8 to 3 टेस्ला के आसपास होता है, 3 टेस्ला होता है। सो नाउ यू नो दैट एग्जाम्पल, आई कंफर्म विद हिम। नाउ व्हाट इज द मैग्नेटिक फील्ड ऑफ अर्थ? मैंने ऑप्शंस दिया 4, 10 टेस्ला, 1 टेस्ला, 1 गॉस, 0.1 गॉस, 4 है। Okay, let us guess. Let us take another statement. Who is powerful? Earth is a powerful magnet, or the small magnet which we use on the fridge is a powerful magnet? एक स्मॉल आयरन नेल ले लीजिए, क्या अर्थ ऐसा खींच रहे? वही जो बार मैग्नेट है तो खींच ले, तो हु इज पावरफुल? नहीं, if you say like this also, if you take iron nail, and I never felt that earth pulls, but if you take a small magnet,
नेल गिरी है, जमीन पे गिरी है नेल, उसके पास आप मैग्नेट ले जाओ, नेल किसको चिपकेगा?
अर्थ को या मैग्नेट को? तो हु इज पावरफुल, अर्थ और मैग्नेट? नहीं, हो सकता है वो ग्रेविटेशन की वजह से गिर गया, बट जब मैग्नेट लेकर जाते हैं तो आयरन किसको चूज करते हैं, मैग्नेट को, अर्थ को? मैग्नेट को। सो हु इज पावरफुल? द स्मॉल मैग्नेट इज ओनली पावरफुल। सो फ्रॉम दिस कैन यू गेस व्हाट इज द मैग्नेटिक फील्ड ऑफ अर्थ? 1 gauss. Okay, let me tell you, it is Earth's magnetic field is roughly 0.3 gauss. Not even 1 gauss, 1/3 of a gauss. Okay, उस मैग्नेट का कितना होगा? वो उस मैग्नेट को कितना होगा जो फ्रिज के ऊपर चिपकाते हैं हम वो सब चीज? उस मैग्नेट का जो ब्लैक कलर में फेराइट मैग्नेट बोलते हैं, उसका मैग्नेटिक 1 gauss. Usually they are 20 to 30 gauss, the small magnets which we use in projects also. Okay, so usually ferrite material से जो मैग्नेट्स होता है उसका मैग्नेटिक फील्ड बहुत कम होता है, about 100 to 200 gauss मैक्सिमम होता है. So if you want little more magnetic field, so people prepared neodymium magnets. Neodymium is another material, so they compress the neodymium materials, and you can see that silver color, those magnets which we use here, they are neodymium magnets. They are little more powerful. So from 1000 gauss, 4000, 5000 gauss also you can get. But they are costly, but we can get up to 5000, 6000 gauss. But we won't get 10,000 gauss also. 5000, 6000 gauss, but 10,000 gauss also we don't get permanent magnets. So 10,000 gauss and above if you want, or 1 Tesla you want, 3 Tesla, like he said in MRI 3 Tesla we require. So can we use a permanent magnet? They are not available at all. Do you know that can I add magnets and get an addition of magnetic field? Can I add 2 magnets and make one magnet 4000 gauss, another magnet 4000 gauss? If I join them, will it give them 8000 gauss? No, magnetic field is not additive. ऐड नहीं कर सकते, नहीं कर सकते, कर सकते नहीं कर सकते पता नहीं मैग्नेटिक. See, is there something which you can't add? Why they won't add? What is the problem for them to add? But it is very difficult to get a more magnetic field, because we are not trying to use the magnetic field, just net the magnetic field, and you know the magnetic field decreases as you go away. So if there is one magnet, there is magnetic field due to this fellow. If there is another magnet, there is magnetic field due to that fellow. So you can get more magnetic field, that is not a problem. So but still you can't get very high magnetic fields, and if you use a permanent magnet, the magnetic field surrounding it is fixed. You do that small experiment, no, magnetic north pole facing north, that magnetic field lines. So the magnetic field of permanent magnet is fixed. For example, if you want a magnetic field like a Mendu vada or cycle tube shape, like that I want, the magnetic field should be in the cycle tube, not in the volume, outside volume. Only in the tube volume you want magnetic field. and that too, that cylindrical shape magnetic field you want in that cycle tube only. So और you want some अजीब से कोई ऐसा शेप में ही मुझे मैग्नेटिक फील्ड चाहिए और आपको पर्टिकुलर वैल्यू चाहिए. So can we use permanent magnets? No. If you want a desired shaped magnetic field, desired value magnetic field, and the third important, if you use a permanent magnet, always there will be magnetic field. If you don't want magnetic field, you can't have control. It always, forever it produces. So I want now a magnetic field. After some time, I don't want magnetic field. So due to these limitations of permanent magnets, we go for another category. In physics, we have an option, something called electromagnets. What do you mean by electromagnet? Yes?
Magnetic field lasts as long as electric current is passed through.
Yes. So an electromagnet is a electric conductor. Electromagnet is nothing but a electric conductor with current in it. If there is a current in a conductor, it acts like a magnet, and this magnetism is due to electric current. That's why we call this magnet as electromagnet. Electromagnet. So do the wire connecting this bulb has a current in it? So do that wire act like an electromagnet? Yes or no? Do the cable connected to this bulb acts like an electromagnet or not? The example is fixed. And yesterday we have seen the current is roughly how much? 0.3 ampere or less only. Yes. So one thing is, these don't act like electromagnet because we have taken a two wires. In one wire current is in that direction, the other wire the current will be in the. So the net current due to that fellow outside is 0. So the magnetism is cancelled out due to the two wires. That's why we don't see any magnetism. That is the wire we lay down the two wires. But in our book, we take one wire like this and another wire we bring like this. But in real life, we don't do like that. We take both wires at a time and you join at the two ends. So, but if you take two wires separately, will you have magnetic field? Yes. But definitely it is 0.1 ampere. The magnetic field will be very less for us to feel. If you have some sensors, we can measure. That is not an issue. So these are electromagnets. So electromagnets advantages is whenever you want current, magnetic field, you just have a current in it. If you switch off the current, no magnetic field. Very good. So you can see these electromagnets in big car sheds. वो पूरा कार को उठाते. So they take a big fellow. They will have a current in it. It will act like a magnet. पूरा कार को उठा देते, रख देते. फिर switch off the current, छोड़ देगा. So that is very easy. Okay. So these electromagnets. And on what parameters the magnetism depends. If you want more magnetism, what you should do? Current बढ़ा दो. But there is a current limitation if you have a thin wire. For example, he wanted 3 Tesla. For example, if you for your information, our tokamak SST tokamak का coil का center में भी we want 3.2 Tesla. About 3 Tesla we want. So if you roughly calculate how much current it should be there in the wire, 12th class वालों को तो पता है formula क्या होता है. What is the relation between current in a wire and distance, and at that distance what is the magnetic field? उस formula का नाम क्या है? Yes, Biot-Savart's law. Both T's are silent. Okay, it is Biot-Savart's law. दोनों T silent है. Okay, Biot-Savart's law says that if the current is this much at this distance, the magnetic field will be this much. That is the relation between current and magnetic field with a distance in it. So do the magnetic field change with the shape of the current conductor? Yes. So that only we study that it depends upon the shape of the conductor also. So and the most important, definitely as distance increases, magnetic field decreases. Whether permanent magnet or electromagnet, as you go away, the magnetic field decreases. That is not a problem. Now the thing is, if you want more magnetic field, definitely current should be more. But the capacity of the wire is fixed. If you take a wire, for example, the maximum current it can carry, it can have is, let us say, 10 ampere. But if you want 3 Tesla, for example, in that configuration, if you try to calculate 3 Tesla के लिए चाहिए हमको 10 lakh ampere. If you have 10 lakh ampere, then only there it will have 3 Tesla. So, do you know any fellow who can carry? So, that's why, yes, in physics we have an option that no material can have that much current. So, always physics give you option. So, rather than having 10 lakh ampere in single fellow, you can take a wire 1 ampere and make 10 lakh turns. It will do. So, if you take a 1 turn 1 ampere, second, so all the currents are in the same direction, so this bunch will act like a single conductor. So, that is one option. So, what we can do? If you want more current, so yes, if you have a less current rating wala cable, then you do number of turns. So, that is the reason in our coil also we do 100 turns. So, in one turn how much we will have? 10 lakh by 100? 10,000. Okay. Actually वही होता है, suddenly if I ask first class question then ये blank हो जाएगा. Okay, it is 10,000 amp. So 10,000 ampere is also very big, that's why we use superconducting. So in the superconducting strand we pass about something like 10,000 amp current. Yes. Okay. So in electromagnetism here what we will do, the first thing is we will make some electromagnet. How will we make? You take a small spindle or bobbin, you just wind it. So if you have a current in it, then it will act like a magnet. So हमको ज़्यादा magnetism के लिए क्या करेंगे? हम number of turns ज़्यादा करेंगे, because our current will be very very less, because we take a wire which will have hardly 0.3 ampere, 0.2 ampere. But if you try to calculate, if you are doing a 12th class problem, you just go home and see straight current conductor के साथ for example you take a wire and उसमें कितना current है, तो 5 centimeter या 10 centimeter में something like 100 Gauss. See, room normally it is how much? 0.3 Gauss or 0.4 Gauss. So let us say 100 Gauss. For 100 Gauss magnetic field at something like 10 centimeter, what should be the current? So you do those things. Actually when you do problems, you should remember those results. So if I have a 1 ampere current at 1 centimeter or 10 centimeter, what is the magnetic field? If you know that answer, no, you can nicely do whatever without doing problem also you can do. If that fellow gave 5 ampere, from your intuition you can multiply by 5 times. If that fellow increase the, rather than 1 centimeter, 10 centimeters, you can do by 10 times, something like that or something. So if you know those, remember the standard values, feel the values, then you can do the problems very easily. So at least you know whether I have done correctly or not by seeing the answer. So you just get a feel. Now you know what are the units of magnetic field. So now you can try to calculate and feel those units. So we will make a small electromagnet. So we will connect a cell and it will act like an electromagnet. ये किया कोई पहले? So we will do. So उसके लिए क्या करेंगे हम? कुछ बच्चे 50 टर्न्स कर लेंगे, कुछ बच्चे कुछ 100 टर्न्स करेंगे. So number of turns बढ़ाए तो क्या हो जाएगा? So you can feel it. Everybody we need not do two things. Okay. And some people they can make a bigger coil. Some people they can make. So उसका सेंटर में we can try to feel, जैसे coil से दूर जाते समय कितना magnetic field. So हम ये magnetic field कैसे feel करेंगे? कैसे फील कर सकते हैं मैग्नेटिक फील्ड? आप फील कर सकते हैं मैग्नेटिक फील्ड को? If it is attracting, it is okay. But to get a little more figure, we have something called Gauss meter. Like voltmeter, ammeter, we have a to measure magnetic field. And a simple way without any number to whether what is the direction of magnetic field, we have something called compass needle. The compass needle will deflect towards the north pole. So whichever is the magnetic field direction, it will try to. So we have compass needles, we have Gauss meter. So you can feel it. If you are going away from the magnetic coil, the magnetic field decreases. If you come towards the coil, the magnetic field increases. So those things we can feel. So what you will do, you will make 3 different types of coils: bigger coil, smaller coil, and number of turns also you do different. This thing we will do in the next experiment also. So I will brief the next experiment also. Okay. So this is about electromagnetism. So if you have a current, you will have magnetism. Now the next thing is, people will get a doubt. If there is a magnetism, will it produce electricity? If you have electricity, it produces magnetism. If there is magnetism, can it produce electricity? Okay, that is what the next experiment, what Faraday has done, what we call it as electromagnetic induction. Yes. So the next experiment is the inverse of the things. If there is magnetism, can we have electricity? Yes. Actually, our electricity is produced like that only. So called our AC generators work on this like that only. Okay. You know that turbines के ऊपर पानी गिरता है, turbine rotate होता है, electricity generate होता है. But actually उसमें क्या होता है? यस, एक्चुअली टर्बाइन के अंदर मैग्नेट्स होता है. जब पानी गिर के टर्बाइन रोटेट होता है, मैग्नेट्स घूम जाता है. मैग्नेट्स घूम रहे तो मैग्नेटिक फील्ड इज ऑल्सो चेंजिंग. टाइम के साथ मैग्नेटिक फील्ड इज, in physics there is know that if magnetic field is changing with time, it will induce voltage. What do you mean by induce? Well, applying a voltage and inducing voltage, what is the difference?
The voltage is created.
Applying means we are using an external source to provide the voltage, and inducing means the source itself is generating a voltage.
Yes, yes. So here we don't do physical connection. Voltages are there. Like I am imparting, I am inducing knowledge in you. ऐसा कुछ वायर मेरे मुंह से या मेरे से आपको कोई न्यूरॉन्स को वायर कनेक्शन करके आई एम नॉट ट्रांसफरिंग. आई एम जस्ट टेलिंग इट इज गेटिंग इनटू यू. सो दिस इज इंड्यूसिंग. सो इफ द मैग्नेटिक फील्ड इज चेंजिंग, वोल्टेज इज इंड्यूस्ड. उधर आपको वोल्टेज लेना है तो ले लो, नहीं तो नहीं. बट द वोल्टेज विल बी देयर इन द स्पेस. So wherever the magnetic field is changing, the voltage is induced in that volume. Now who can feel a voltage? If there is a voltage difference, who can feel them? Conductors or insulators? Yes, if you put a conducting wire in that space, there will be a current. Okay. So in the generator, what we will do, when the voltage is changing, they will put a wire. So in that wire, current will be there. So in this way we do it. So in the second experiment, what we will do is, we will try to change the magnetic field and we see whether current voltage is induced or not. ये कैसे करेंगे? We will take a coil. और ये भी कैसे, how much magnetic field depends on these things is the coil. Say in the first experiment जैसे number of turns है, in this experiment also the voltage induced in single loop and the voltage induced in many loops. You know voltage is added if you do it in series. So what we will do, let us take 50 turns. So in the 50 turns the magnetic field is changing. So if one loop magnetic field changing induces, let us say V1. So in 50 turns, 50 times it will be induced, so you will get more. So in the second experiment also what we will do, we will take a 50 turn loop, we will take a 100 turn loop and just take a magnet and do. If you are just moving the magnet, the magnetic field is changing. So you can see the voltage induced. So like that we will do the 2-3 experiments. One is by moving the magnet, physical magnet. In the second experiment, in the same thing, already we prepared electromagnet. So rather than permanent magnet, we use the electromagnet. Then also the magnetic field is changing. And the third piece of the experiment is, so we have to change the magnetic field. So in the first experiment, when there is a current, there is a magnetic field. If the current changes, the magnetic field also changes. For example, if I give a current from this fellow, the current due to this fellow will be changing. जब मैंने सॉकेट में रख दूंगा तो AC है, the current is changing. So the magnetic field also changes. So definitely have a coil, just उसका input में मैं AC current दूँ, AC voltage दूंगा तो AC current रहेगा. So this AC current makes the changing magnetic field. So changing magnetic field induces. So these are the three things we will do in the electromagnetic induction. Okay, these two experiments we will do prior to lunch. So the important part is we have to make coils. Okay, different coils, different dimension coils, let us make. Yeah.
हाँ उसका था यहाँ से कौन सा फिर देखो क्या इसी बराबर बोला वाला ये हुआ है हाँ
You take your coils, and we have some 4 or 5 power supplies. So whichever you want. So you have to more than one, no? So you connect one coil to a power supply and do the things. जो small bobbins वाला है उनके लिए we will use pencil cells, and जो big coil wind किया उन लोगों के लिए हम power supply use करेंगे. So we will connect a coil to a power supply. We will have some current in it, and magnetic field देखेंगे. So magnetic field के लिए क्या करेंगे? We will take some iron nails and check it. That only we can do, or we can take a gauge meter or compass needle and we will check whether it is acting. Okay, so we will be ready with our compass needle also. So take one compass needle and go to a power supply. जो small bobbins wind किया, we will use a pencil cell. Okay, so let us do that experiment. नरेंद्र भाई बस झूले को रख दो, झूले लाल. ओके नरेंद्र भाई. नरेंद्र आवाज. Welcome back after lunch. We have one main experiment and one small experiment for this session. So we have seen how electricity results in magnetism, how magnetism results in electricity. If you see the electromagnetic induction, the magnetism is producing electricity with the help of mechanical motion, isn't it? So you are moving the magnet. So there is magnetic field and there is some mechanical energy also involved with it. So both combination is resulting in electric energy. So that means electric energy, mechanical energy, magnetic energy, three are related. So if those magnetic energy and mechanical energy resulted in electric energy, can electric energy plus magnetic energy results in mechanical energy? Yes. And we all know these things. Electric motor. So we just plug in and the motor rotates, but we know that it is only due to electric, but inside there is something magnetic also. So basically an electric field and a magnetic field. If there are two fields, so you will study the cross product, it creates a mechanical, yes, that is E cross B force. So electric field is E and magnetic field is B, and there is something you will study in 11th class, vector product. So E cross B. So that will act some mechanical force on the conductor. So if there is a magnetic field, if there is a current conductor, then there is a mechanical force involved. So that will try to push something. So if that push is something that we can rotate something, then it will rotate. So mostly like our mixer, fan, all these things, they have something like motor. And usually you have DC motors, AC motors. So two types of motors will be there, but here we will make simple, basically a motor. So if there is a current, if there is a magnetic field, will somebody rotate? That we will check. So that principle, so electric field and magnetic field tries to rotate an object. So this device we call electrical energy to mechanical energy conversion is called a motor, electric motor. So how we do these things? We do a very simple motor. So we have a sample. We take a small pencil cell. With the help of paper clips, we will make holders, and with a very thin wire, we make some 10 turns loop, and we will use a magnet on the pencil cell. So the current in the coil is in this direction and the magnetic field is in this direction. So due to the perpendicular thing, the coil will try to rotate. So very simple electric motor we will try to make. Okay. So we will have a cross, electric and magnetic field cross thing acting on a current conductor. So basically that current conductor should rotate. So the connection should not be rigid. So that's why we will make the only technique in this thing is the connection should be just a contact things. It can rotate. It is having a contact, but it can rotate and freely move. That is the only small arrangement we should do in the setup. So we will use these things, very simple experiment this is. So you have to make a small coil. Okay. So this is one thing, and I will discuss the next experiment also. We will not come back after this. So this we call it as eddy braking. So in the Faraday's induction, this is a application or a extension of Faraday's extension only. So we have seen Faraday induction. So whenever there is time varying magnetic field, it is inducing voltage. So if there is a conductor in that zone, current will be there due to the voltage. If you have a wire, we can say the current is in this wire. But let us say there is a very thick copper plate. So what is the current direction in that plate? And will there be only one current path in that plate due to voltage in that area, or it will be many current loops? So basically, when people observed, if there is a voltage in this zone due to time varying magnetic field, so if there is a copper plate, so there will be very small loops will be forming with the currents. So small current loops will form and very huge number of current loops will form. So that means there are small current loops will be forming in that copper plate or aluminum or any good conductor. So these conductors, these currents, what currents will do? We already seen that if there is a current in a conductor, they will act like a magnet. So that means these entire all these currents put together, so that fellow will become like an electromagnet. And all this is happening due to time varying magnetic field. So that means there is a magnet, there is a source which is creating a magnetic field, okay, which is changing, and resultant is also again a magnet. So there is a cause magnet and result also magnet. But how these two magnetic fields will be produced? If you are becoming a magnet, so which side will become a north pole, which side will become a south pole? So ultimately this copper plate or aluminum plate is becoming like an electromagnet. So which side should become, what should be the current direction such that which side should become the north pole and south pole? Which side it should become? So this is called, what is called as Lenz law, L-E-N-Z, Lenz. So Lenz is a scientist who found out that what should be the direction of the current. Then he says that the current will be in a such a direction which will produce a magnetic field that will oppose the causing magnetic field. So if north pole is coming towards you, then current will be such a direction that it will also produce north pole. So if this is a copper plate, if there is a time varying magnetic field, and in this time varying magnetic field, if this is a north pole, and the currents in this body will produce such that it will also produce north pole towards it, so that it will oppose. And if the south pole is coming, south pole. So if the north pole is going away, so it don't want to change. So always the currents will be induced in such a direction that it will oppose the change. It will oppose the, if the north pole is coming, it should produce north pole, because it don't want to increase the north pole effect. If the north pole is going away, it don't want that also. North pole is going away, it don't want to the change. So it will create a south pole so that it will attract it. So if the south pole is coming, it will create a south pole. If the south pole is going away, it will create north pole. So it depends upon how the change is. So always the magnetic field is created due to currents, and those currents will be induced in such a direction, always oppose the change. So that is called Lenz law. So these currents, we call them as eddy currents. Okay, eddy means like whirls in the water. So these eddies, so these currents are called eddy currents. So what is the advantage of these eddy currents now? So unnecessarily a time varying thing is causing a current in you. If there is a current, you will get heated up. Yes, there will be magnetism also. There is actually that small experiment we have not included in the list. Electric current will have magnetic effect. Electric current also will have heating effect. You know that thing. Whenever there is a current, it gets heated up. So due to the currents, that fellow gets heated up also. So there are advantages, disadvantages. If you don't like heating, then it is a disadvantage. If you want heating, so basically if you see a transformer application, in basic thing in transformers, actually this eddy current comes in a transformer topic in your syllabus, where there is actually eddy current is removed from your syllabus, that's why you don't know. So transformers ka last topic is eddy currents, that is removed in your syllabus, 12th class syllabus. So that's why I am telling it will be useful. So in the transformer, what happens, we have seen a primary and secondary. Actually we have seen on two different things, but in reality both are wound on the same coil. एक ही कॉइल लेते उसके ऊपर ही एक कॉइल करते लेते और दूसरा कॉइल भी उसके ऊपर ही करते हैं. and to increase the magnetic flux they use something ferrite material. So, due to this current, no, those fellows eddy currents are induced in that iron material and that fellow gets heated up. So, basically that core or on the frame which the windings are done, so what they do, eddy currents will cause that fellow heating. It's why that's why your adapter gets heated up. आपने देखा आपको अडाप्टर में क्या होता है, जो मोबाइल चार्ज, मोबाइल अडाप्टर या लैपटॉप अडाप्टर, you know, that fellow gets heated up. Why? Why it don't get heated up that quickly, but that adapter gets heated up very quickly? One is due to basically circuit is there, and basic another thing is there is a transformer, because you know your laptop does not require 240 volt. So there is a step down transformer in your mobile charger or laptop adapter. A step down transformer is there, 240 volt to 24 volt or 12 volts. It will step down to 12 volts only, then it will convert to DC and it will give. So first it will down to 240 to 12 volts or 24 volts like that, and it will convert DC and give. So there is a transformer inside those things. So in the transformer, due to eddy currents, it gets heated up. So the transformer, entire transformer in electrical engineering, you will study transformer design. So how to design better transformers, what are the best materials, that is very established technique, but people are improving it. So if you don't want this eddy current heating up, the eddy current should not form. So if the eddy current should not form, that means a loop should not form, because current requires a closed loop. If the loop is not there, then current is gone. So for example, rather than taking a plain material, if you take like a small strip of conductor, another strip insulator, conductor, insulator, rather than an entire thing. So instead of entire conductor, you take a conductor, insulation, like this, then the current which is forming a loop earlier, it can't form a loop now, because a current is there, there is no conductor here, there is a conductor. So conductor, since there is no full conductor, so the path is cut. So a current can't be there in a closed, even though voltage is there, induced voltage is there, but induced current can't be there, because current requires a closed path, so which you are not giving. So the induced voltages are not inducing currents because of high resistance insulating paths. So eddy currents can't be formed, so that's why heating will be less. Okay, definitely, since currents are not there, magnetism due to that also will be lost there. So if you don't, you should not want. So wherever you don't want, so basically those materials, you have a design such that conductor insulator, something like that, or entire. Can we take entire insulating material in a transformer? Basically we take ferrite material because we want magnetic also. Mostly insulating materials are non-magnetic. We want to increase the magnetic flux. See, entire transformer, how it is working, whatever the primary voltage is there, that is creating magnetic field. That magnetic field, when it is changing, it should induce voltage in the secondary. So the secondary fellow should be linked with the primary fellow, first fellow, with magnetic field only. So you should concentrate the magnetic field in that zone only. So that will be helped by magnetic material like iron. But bad luck is that magnetic material is electrically conducting. So that's why we break it. So that is the reason we can't use completely insulating material also for winding these things, even though we use plastic and cotton, this board, because we don't want that much coupling, we want to see the principle. So that's why if you wind it, this is an iron thing, no, you will get very good coupling. So these things. So eddy currents are not useful in transformers or for our tokamak like machines also. In tokamak like machines, how come eddy currents come? How come there are changing magnetic fields? Where do you expect a changing magnetic fields in practical situations? Do you see changing magnetic fields in real life anytime, anywhere? So wherever there are currents, there will be magnetic fields. But you know, current, when you switch it on, will it be instant or will it take some time? When you switch on, will the current value go to 0 to I? It will take some time, and it will be like that only. What do you say? Everything takes time. Okay, it may be nanosecond, microsecond, millisecond, but it takes time. There is nothing called 0. Okay, when you switch off the current, we say I go to 0. From I value, it will go to 0, but it will take some time. Even though we say it is going to 0, but it will take some time. So during that small duration, there is a change in current. So due to the change in current, there is a change in magnetic field. So whenever you switch on the magnet, switch off the magnet, so during that initial time and switch off time, there is a changing in magnetic field due to changing. So the changing in magnetic field will induce huge currents actually in tokamaks. So we don't want. That's why in our tokamak like machines also we have the eddy braking. That entire shell is not conducting. They will have insulation there. So in most of the situations we don't want eddy currents. But here let us see how eddy currents are useful. Do you know any example where eddy currents are useful? You know, सबका घर पे वाटर केटल है, जैसे नीचे एक प्लेट होता है उसको ऊपर रख देते फिर निकाल के हम गर्म करके वाटर केटल बोलते हैं हम. सो दैट वर्क्स ऑन इन दिस एडी करेंट्स ओनली. हाउ? जो नीचे का प्लेट में कॉइल होता है वी विल प्लग इट. तो उस कॉइल में कौन सा करंट है? AC. So that is time varying current. So that produces time varying magnetic field. तो उसके ऊपर voltages are induced. तो उसके ऊपर कोई भी कंडक्टर रखती है तो क्या होगा? उसमें भी करंट होगा. बट इफ इट इज़ नॉट ए वेरी गुड कंडक्टर लाइक निक्रोम जैसे है तो उस करंट की वजह से वो क्या होगा? हीट होगा. सो बस वी विल यूज इट फॉर वाटर हीटिंग. जो इंडक्शन स्टोव बोलते हैं, इंडक्शन स्टोव देखा, दैट इज़ ऑल्सो सेम प्रिंसिपल. किसी का घर पे ख़राब हो गया या यूट्यूब में देख लीजिए मैकेनिज्म ऑफ इंडक्शन स्टोव, और ऊपर का ग्लास निकाला तो यू विल सी नाइस कॉइल. सो बेसिकली so to get a more area. So same thing, induction stove is mostly or the eddy currents are used for heating. Our induction stove, water kettle, all these things we use. And these two things, another application is basically eddy currents are used for braking. We call this as eddy braking or non-contact braking. You know, in our normal vehicles like cycles and other things, when you apply a brake, एक rubber like fellow will go and hold the wheel. इसके वजह से स्पीड कम हो जाता है. सो व्हाट डू यू मीन बाय ब्रेकिंग? डिक्रीजिंग ऑफ स्पीड इज कॉल्ड ब्रेकिंग. इन मोस्ट ऑफ द केसेस इट गोज टू जीरो, बट इट नीड नॉट बी. ब्रेकिंग मीन्स डिक्रीजिंग ऑफ स्पीड. सो व्हेन यू पुट द थिंग्स, द रबर विल गो एंड होल्ड द व्हील एंड इट विल नॉट रोटेट. बट व्हाट डू यू सी दीज डेज? वेरी फास्ट मूविंग व्हीकल्स लाइक 200 kilometers per hour, 300 kilometers per hour. So do you expect that if you apply a brake, there will be something rubber like thing and go and hold the wheel? What will happen if you hold the fellow moving at 200 kilometers per hour speed उस wheel को? या बेसिकली फ्रिक्शन इतना ज़्यादा होता है, पहले चीज़ वो टॉपल दिस और रबर विल मेल्ट अवे उस फ्रिक्शन की वजह से. सो यू कैन नेवर अप्लाई दिस यूजिंग योर नॉर्मल ब्रेकिंग सिस्टम फास्ट मूविंग व्हीकल्स. So if you want to apply brake without touching, you should apply. How to do that? Eddy braking. So we know that this changing magnetic field causes a magnetic field and will oppose it. So if you are opposing, what will the opposition will do? It will slow down. So that's what braking. So without touching, we use this principle in braking. So in very high speed trains or cars, actually जो कार में जो 200-300 स्पीड में जाते हैं कार्स, when you apply brake, फर्स्ट इट विल डू दिस नॉन कॉन्टैक्ट ब्रेकिंग. एक लिमिट आने के बाद 40-50 किलोमीटर्स आने के बाद नॉर्मल वाला चले जाता है. इट विल यूज डबल ब्रेक सिस्टम इंटरनली. यू अप्लाई ओनली वन ब्रेक बट इट विल डिक्रीज थिंग्स. इट विल चेक द स्पीड. वंस इट कम्स टू नॉर्मल स्पीड्स इट विल यूज द नॉर्मल ब्रेकिंग. बिकॉज एडी दीज थिंग्स कांट अप्लाई एट लो स्पीड्स. लो स्पीड्स में इतना फर्क नहीं होता एडी कर, बिकॉज यू नो दिस टाइम वेरिंग चाहिए ना. इफ़ यू आर मूविंग वेरी स्लोली then the time varying is very slow, it may not induce that much currents. The fast you change, then the more you induce. So the slow moving devices, these eddy currents will not be very effective. So these are used in these, sometimes it is also called as regenerative braking. Yes, and practically this eddy braking is used in what is this? ये मेला में कार्स होता है ना, what do we call these things? Roller coasters. The roller coasters का brake system, everything is eddy current braking only. So the roller coasters का brake normally, because they move very fast, so these eddy currents are very effective in their braking. So eddy braking is effectively used in roller coaster braking. So sometime if you go and see the video, the roller coaster का braking, so you can very clearly see. So these things we will see here. So we have an experiment with 3 elements. So first we have a setup with a copper pipe, aluminum pipe and a plastic pipe. So I will drop a magnet. So due to gravity, the magnet will fall down. So as the magnet is moving, the magnetic field is changing. So the moving magnet will change the time varying magnetic field, that will induce a voltage. उस वोल्टेज की वजह से कॉपर पाइप में तो कुछ नहीं होगा, सॉरी प्लास्टिक पाइप में कुछ नहीं होता, इसलिए दो नो अपोजिशन, द मैग्नेट विल फॉल वेरी इजीली. बट इफ यू डू इन द aluminum, what happens? So aluminum is a conductor, so eddy currents will induce and it will act like a magnet, it will oppose. So it won't oppose that much, gravity जितना opposition नहीं होता, but that's why since it is opposing, its speed decreases, it will be little slow. But if you put it in a copper pipe, copper is a still good conductor than aluminum, so more currents are produced or higher currents are induced in it. So higher current means more magnetic field, more opposition, so it will fall very slowly. You can see the time difference. एंड साथ में हैव ए पेंडुलम एक्सपेरिमेंट ऑल्सो, जो आपका 12th का टेक्स्ट बुक में होता है वो पेंडुलम एक्सपेरिमेंट, वी विल सी दैट. एंड वी हैव ए ब्रेकिंग सिस्टम ऑल्सो, कार्स वाला है, ब्रेक्स वी कैन सी. सो दीज आर द 2 experiments वी विल डू. ओके, yes. So first we will make an electric motor. I prepared one electric motor, simple one, I will show you. You should prepare like that. वी रिक्रूट इलेक्ट्रॉनिक्स पीपल नो, तो हमको फिजिक्स वालों को बोलते हैं मुझे जो चाहिए वो बोल देंगे, जो मुंह में आते हैं वो बोल देंगे, बिकॉज दैट इज अवर रिक्वायरमेंट. यस, तो जनरली this was the one of the starting in failed works of Tesla. His idea was to do wireless electricity. So हर गांव में without electric poles and wires electricity transmission कर. यार ये सब रिकॉर्ड कर लेते यार, जो नहीं बाद में मुझे शाम को बैठ के मेरे वीडियो एडिट करना पड़ेगा. Okay, yes. So that was a failed experiment. That's why till today we use wires and poles, because here we will see with 30,000 volts what is the distance wirelessly we will do it. So if you want entire village, so let us see these things. Magic करते हैं ना, आ जाओ. हाँ आ जाओ. Hold this. Don't touch it. Go close. Go that side. Don't touch it, huh? Just you can go close. जा वो लोग है तो भी जा सकते हैं. लाइट बैटल्स होते हैं ना, लाइट आ जाते हैं बैटल. नहीं रुको. Almost that distance only you are getting. I have different sodium gas in it. Okay, I will close and stop and again we will do it again. Okay, बाकी सब बच्चे करें. Okay, sorry. Okay, yes. Now you have to tell me without connection how come this fellow is getting energy. That's why it is glowing. So it is glowing because it is getting energy. We studied in basic our 10th class circuit, closed circuit नहीं है तो, but how come this fellow is getting energy without a circuit at all? There is a source. But how come without a circuit this fellow is receiving energy? That's why it is glowing. How come? हमारा fundamental line violate हो गई ना. Circuit is required, closed चाहिए. क्यों? Because I have shown wire. Without wire, I can glow these things. आप जो भी बोलेगा आपका फ्रेंड्स हाँ बोलना चाहिए, मैं नहीं. उनको कन्विंस करना चाहिए. क्या लगता है हमारा टेक्स्ट बुक में गलत पढ़ा है? हाँ या ना? डाउट आ रहा है? अभी प्रूव हो गया गलत है. नहीं, वो गलत भी नहीं. देखो हमारा सर्किट कहीं भी ओपन है तो सर्किट नहीं चलेगा. दैट इज ऑल्सो ट्रू. दिस इज यस. एक्चुअली वोल्टेज ज़्यादा होने से क्या हो रहा है? So the fundamental question is, in electricity, who stores energy? Okay, in gadget, but
Charges.
okay. Since he said capacitor, where is energy stored inside a capacitor? Don't tell. I will give option. Inside the plates, on the plates, between the plates. Fourth option नहीं है. It won't store energy. Capacitor don't store energy. None of the above. Capacitor. First of all, actually इससे पहले दूसरा पूछना चाहिए. Capacitor stores
Yes.
current, voltage, energy, charge.
Charge. Capacitor stores charge.
Capacitor stores energy. Yes. Capacitor stores energy. Charge can't be stored. You don't store charge there. You store energy. Capacitor किसके लिए यूज करते हैं हम? एनर्जी के लिए यूज करते हैं. Capacitor stores energy. So how it stores is something different, but it stores energy. Nobody stores charge.
So energy is contained in charge. So technically, if we contain charge, then only we are containing.
But let me tell you, as a overall, if you see a capacitor, it is neutral. How much negative charge is on that fellow, that much positive charge is there. So overall, a capacitor, it is electrically neutral. So that's why it won't store charge. You separated charges. You did not store charges. Okay, that's why we don't store charge. So in doing this separation business, they store energy. So capacitors store energy. Okay, it won't store current, charge, voltage. Okay, it store energy. So first thing is, if you know that, then the thing is, if store energy, where is energy stored? Inside the two plates, on the two plates, between the two plates. Do you know the formula of the capacity of a capacitance? क्या है? नहीं इसमें इलेक्ट्रिक फील्ड बिटवीन टू प्लेट्स का फॉर्मूला क्या है? इलेक्ट्रिक डेंसिटी, इलेक्ट्रिक एनर्जी स्टोर्ड इन ए कैपेसिटर इज ई स्क्वायर बाई 2 2 एप्सिलॉन नॉट ई स्क्वायर बाई 2 एप्सिलॉन नॉट. तो उस फॉर्मूला में ई भी है, एप्सिलॉन भी है. तो परमिटिविटी ऑफ फ्री स्पेस एंड ऑल्सो इलेक्ट्रिक फील्ड. सो बिटवीन द टू प्लेट्स मीडियम भी है, बट बिटवीन द प्लेट्स मतलब जनरली हम क्या समझते हैं, मीडियम है, मीडियम स्टोर्स एनर्जी है. बट लेट मी टेल यू, इट इज़ नॉट, द मीनिंग इज नॉट बिटवीन द प्लेट्स मीन्स इट इज़ नॉट मीडियम, इट इज़ इलेक्ट्रिक फील्ड. One is positive plate, one is negative plate. So between the two plates, what is there? Actually, between the two plates, electric field is there. So actually, हमको medium है ऐसा, that we think, but it is electric field which is storing the energy. So in a capacitor, who is storing the energy? Electric field. Not only capacitor, whenever there is a electric energy, who stores the energy in electricity language? Electric field. So when you have a charge, there is an electric field surrounding it. So this electric field stores energy. So as you go away, electric field decreases. That's why energy also decreases. So at this point, whatever the electric field is having energy, that is sufficient to glow this bulb. That's why this bulb is glowing. So to have a sufficient high energy, the electric field should be high. And you know, electric field and potential are related. So that's why when we apply very high potential, the electric field is very high. And that means it is energy is very high. Electric field is high means, think only thing. What do you mean by electric field is high? Electric field is high means the energy at that point is very high. That is the meaning electric field. Okay, electric field ज़्यादा होने से मुझे क्या होता है? Electric field ज़्यादा होना मतलब energy ज़्यादा होना. So that's why this energy is sufficient to glow the bulb. Is it sufficient to charge my mobile phone? Yes, इसीलिए आजकल वो वायरलेस मोबाइल आता है ना, सेम प्रिंसिपल. बट द थिंग इज ऐसा हर एक का टेस्ला कॉइल के ऊपर खरीदे तो एप्पल का चार्जर कोई नहीं खरीदेगा. दैट्स व्हाई दे सेट चार्जिंग एट वन पर्टिकुलर फ्रीक्वेंसी. जैसे इसमें मैंने 633 किलोहर्ट्ज़ है, दे विल हैव सम देयर पर्टिकुलर फ्रीक्वेंसी, दोनों को सेट कर लेते हैं, उसी फ्रीक्वेंसी पे वो चार्ज होता है. अभी आप मेरा मोबाइल इधर रख दो ना, ऑटोमेटिक किसी को कॉल जाएगा, व्हाट्सअप मैसेज जाएगा, बिकॉज वो ओपन करने के लिए एक फ्रीक्वेंसी होता है ना. इफ दैट मैचेस नो, इट विल डू ऑटोमेटिकली. नो, आई डोंट वांट टू स्पॉइल मोबाइल. मेरा हो गया गौहती में, मुझे पता नहीं, पहले फर्स्ट ईयर था उस समय, तो मैंने ऐसे ही उस एग्जीबिशन में मॉर्निंग टू इवनिंग आई वाज सपोज टू एक्सप्लेन दिस, तो ऐसा बाजू में रख के एक्सप्लेन कर रहे हैं. तो नहीं, मोबाइल खराब नहीं करना, नहीं होता है. नीरज सर से मोबाइल मांगना नहीं. So actually, you know, in these gadgets, everything is set with particular frequency. ये हम दबाए तो एक frequency अंदर एक LC circuit होता है, it will generate that frequency and open to these things. So इसमें तो it is generating 633 किलोहर्ट्ज़ का इधर उधर का frequency चल रहा है. तो किसी ने कोई एक frequency जैसे, और उस समय तो मेरा इसमें मेमोरी कार्ड भी गया, BSNL सिम कार्ड गया, मोबाइल तीनों गया, क्योंकि मॉर्निंग टू इवनिंग 3 days था. तो बाद में पता चला 3 दिन मोबाइल काम क्यों नहीं कर रहे, पता नहीं. उस समय देन आवर हेड सेज दैट आप टेस्ला कॉइल के बाजू में बैठा है. हाँ सर, 3 दिन उसके बाजू में ही बैठा है. यस, तब से ये मैं एक्सप्लेन नहीं कर रहे थे. ओके, एक्चुअली दिस थिंग नो अर्लियर वी यूज टू सी इन ए मैजिक शो. एक ब्लैक वो कर्टेन होता है, कर्टेन के पीछे होता है, और जैसे ये चालू होता है आवाज़ होता है ना, ये आवाज़ ना सुनने के लिए अच्छा गाना बजाते हैं. और वो जो, एंड इफ यू सी दिस थिंग, दिस ट्यूबलाइट्स आर नॉट न्यू ट्यूबलाइट्स आल्सो. These are gone actually. These were thrown in the waste one. ये उड़ गया actually. It won't run in. देखो, if you see there is no filament also.
इसमें गैस तो भरा ही है.
So nothing. Filament is also not there. गया काम. This won't run in your normal thing. So okay. So but why we require wires in our house? If electric field is giving energy, then what is the role of wires?
कोई भी नजदीक आ जाएगा तो क्या होगा?
नहीं, डेफिनेटली 30,000 वोल्ट है. 30,000 वोल्ट को इधर जल रहा है, पूरा घर पे चाहिए तो हाउस होल्ड नहीं. 30,000 के लिए इधर ही चल रहे हैं, पूरा गांव में चाहिए तो लाखों वोल्ट चाहिए. वो महंगा भी है, रिस्की है. देन द पीपल सेड दैट नो वी विल प्रोड्यूस 240 वोल्ट से सस्ता एल्यूमिनियम कॉपर वायर डाल के जला देंगे. सो एंड उस समय क्यों जो बनाते हैं वायर है तो बीच में मीटर लगा के पैसा लेते हैं. वायर लेते तो मीटर कहाँ लगाएं, इसीलिए तो. But this gave an idea at that time that even though wireless electricity is not possible, wireless signal transmission is possible. See, light is a form of signal. So you are transmitting light. So that gave an idea for our DTH connection and cell phones, which we are enjoying the wireless TV and mobile transmission. So this is not possible, but every failed experiment will trigger some other experiment. So that's why. So this is one thing. But my answer is, in our house, how are the electric wires helping us? If electric field is having energy, then what do wires do?
But wires transmit to a particular
What they
appliance,
transmit? Why?
current, energy.
तो आपको लग रहा है current is helping to give energy to the bulb?
Yes.
Do the current in a wire give energy to the bulb? Do the electrons moving in the wire, what we call current, transmit energy to the bulb? Yes or no? The potential difference is across the two wires at the 2 points. So when you connect two wires in the things, there is a current, the electrons are moving. So those electrons carry energy from the socket there and give to the bulb. Yes or no? Yes. ऐसा है तो पहला बल्ब पहला जलना चाहिए, बाद में सीरीज में बाद वाला बल्ब बाद में, ऐसा. और पहले वाला पूरा जितना एनर्जी चाहिए उतना एनर्जी लेकर ज़्यादा ग्लो होना चाहिए, और कोई बचे तो दूसरा वाला ग्लो होना है, नहीं ग्लो होना है. ऐसा होता है? नहीं होता. सब साथ में एक ग्लो होता है. तो क्या है? ऐसा जाते समय ऐसे कैसे दे दूंगा? पहले मुझे कैसे पता है कितने लोग हैं? और ऐसा, दिस इज वन रीजन टू लॉजिक. एंड सेकंड रीजन, यू स्टडी समथिंग कॉल्ड ड्रिफ्ट वेलोसिटी इन योर. So what is drift velocity? The velocity with which the electrons move in a wire is called drift velocity. I don't know whether you have done that problem calculating the drift velocity का एक problem होता है. कितना स्पीड आता है वो velocity, वो वैल्यू कितना आता है, किसी को याद है? I don't know.
6.25.
Yes. Okay. Now, let me tell you, the electrons move in the wire less than what your two-wheeler moves. इतना स्लो जाते हैं electrons. If you try to calculate, it is not even meters per second, kilometers per hour तो दूर. So with that speed, if it has to go, no, it will take half day, 1 day to go to the next building. But इधर switch on किए तो next building क्या, पूरा जो street lights देखो, एक ही जगह switch होता है, पूरा 5 kilometers का. So it is very instantaneous, isn't it? So that means the electrons are not taking energy. If the electrons are taking energy, तो पहले वाला को पहले देना चाहिए, और बाद वाला कट है तो भी ओपन सर्किट है तो भी क्या प्रॉब्लम है, उधर तक तो जाकर उसको दे सकते हैं. सो द कंक्लूजन इज, द बल्ब गेट्स एनर्जी नॉट बिकॉज ऑफ electrons. Electrons will never give energy. Then what do that energy of electrons do? Electrons enjoy that energy. They are like brokers. ऊपर ने सेंट्रल गवर्नमेंट ने फंड रिलीज किया, हमारे तक आने में बीच में बहुत सारे लोग होते हैं ना, वो लोग है इलेक्ट्रॉन्स. वो लोग एनर्जी लेकर वो गर्म हो जाता है, हीटिंग हो जाता है. ओके, दे विल ऑल्सो टेक एनर्जी बट दे डोंट गिव एनर्जी टू द बल्ब. ओके, सो वट एवर द बल्ब इज ग्लोइंग, दैट इज नॉट द एनर्जी ड्यू टू विच द इलेक्ट्रॉन्स आर गिविंग, दे आर टेकिंग देमसेल्व्स. तो उसका मेहनत से वो ले रहे उस पॉइंट पे. सेम थिंग, हाउ दिस इज ग्लोइंग एट दिस पॉइंट, इलेक्ट्रिक फील्ड में जितना एनर्जी है वो ले लिया. वो बल्ब भी क्यों जल रहे, उस पॉइंट पे जो इलेक्ट्रिक फील्ड का एनर्जी है वो ले रहे, बट विदाउट स्विच ऑन वो नहीं जल रहे. स्विच ऑन करने के बाद वो जल रहे. इसका मतलब है पहले उधर इलेक्ट्रिक फील्ड बहुत कम है, या ओपन सर्किट है तो भी कम है, बट वायर के वजह से उधर इलेक्ट्रिक फील्ड ज़्यादा हो गया, इसीलिए एनर्जी ज़्यादा हो गया. सो इफ़ यू वांट टू नो दिस थिंग्स, देयर इज अनदर टॉपिक, व्हाट हैपेंस इफ ए कंडक्टर एंटर्स ए यूनिफॉर्म इलेक्ट्रिक फील्ड. वो टॉपिक भी होता है आपको 12th क्लास में. आई डोंट नो, यू नो, देयर इज ए यूनिफॉर्म इलेक्ट्रिक फील्ड. एक कंडक्टिंग बॉल आया, so how the electric field lines changes? Don't remember that topic. Okay, what a conductor will do, it will attract the electric field lines. So if you see the topic, for example, if the uniform electric field is there, तो lines ऐसा draw करेंगे. जैसे एक copper ball आया, तो what it will, all the lines, चारों तरह का लाइन्स उसके तरफ नज़दीक आ जाएगा, या उससे ज़्यादा, उसके अंदर तो नहीं जाएगा कंडक्टर, मगर सरफेस में नज़दीक आएगा. तो व्हाट ए कंडक्टर विल डू, इट विल पुल द हॉट इलेक्ट्रिक फील्ड टुवर्ड्स इट. तो पहले स्विच चालू करने से पहले जो उधर जो 230 वोल्ट्स है ना, 2 होल्स के बीच में, उसके वजह से इलेक्ट्रिक फील्ड इधर है, बट दैट इज एंटायरली स्प्रेड इन द स्पेस विच इज नॉट सफिशिएंट टू ग्लो द बल्ब. जैसे आपने प्लग लगा दिया, ये पूरा फील्ड लाइन्स क्या किया उस कंडक्टर ने, सो द कंडक्टर हैज पुल्ड ऑल द फील्ड लाइन्स such that the energy is sufficient to glow the bulb. That's all. So the conductors are only pulling the field lines towards the conductor. और उस conductor पास में कोई भी है वो सब लोग ले लेंगे. And how much time will take this pulling of electric field lines? It is at the speed of the light. That's why when you switch on, all the things will be done immediately. Okay? So it is the electric field which transfers the energy to the bulb, not the electrons. They also take energy. They don't give.
But they do not give.
No, they also take energy.
But they do not give to the.
Yes, whatever our gadgets are using, that is not because of current. Due to current, the wires heat up. So they don't give energy to these things. Got it? Yes, this is what I want to show, wireless electricity. And why I have to show this experiment? Because due to high voltage, the air is taking that energy and it is going into plasma state. So in air 78% is nitrogen. So what you are seeing is dominant nitrogen. That magenta color, jamli color में जो दिख रहा है, that is nitrogen plasma. So due to the plasma, I am showing the experiment. But since this is a Tesla coil, this much story. Pushpa part 1 and this is Pushpa part 2. नहीं, actually plasma is Pushpa for me. This is Pushpa background वाला story. So okay, this is the story I want to tell. And since we can't touch these things, हमने एक और गैजेट है, इसके ऊपर एक गैस फील्ड ग्लोब्स है. ओके, इसको हाँ, yes, definitely. But I will be here because if you touch it, कल दोस्तों को छुट्टी मिल सकते हैं. हम स्कूल ही नहीं जा रहे, हमारा ऑफिस बेकार है, कल हमको छुट्टी भी नहीं देते, नहीं तो किसी को बकरा बना देते. ओके, बोलते सर शुभ शुभ बोलो बोलते हैं, इसीलिए हम अच्छे शब्द में ही बोलते हैं. ओके, चलो, तो डोंट टच इट, दैट्स ऑल. ओके, यू कैन टच इट.
ये इलेक्ट्रोड दूर रखो, टिप मत लाना.
यस, या ओके, यू कैन पुट इन हॉरिजॉन्टल मोड. हाँ, यस, इधर से आ जाओ, इधर से आ जाओ. ओके, ओके, आई विल आस्क क्वेश्चन, व्हाई यू आर गेटिंग दिस साउंड? ओके,
अब तो सब कलर अलग अलग क्यों है?
कहाँ अलग है? इसमें सोडियम है, इसमें सोडियम है, इसमें सोडियम है.
ओ भाई,
डोंट टच,
एकदम नजदीक.
उसको बैलेंस पकड़,
इसका कांटेक्ट नहीं ले जाए.
जोर से पकड़ो, ऐसा बीच में क्या होता है?
ट्यूब ले जाओ, कांच ले जाओ.
Okay, okay, I will stop for a little bit. Basically what happens when we have a high voltages in the air, basically due to this ionization, oxygen goes to ozone. So small amount of oxygen is converting into ozone and ozone causes dizziness. So longer exposure to this small dizziness. So if you want to operate, just operate with brakes. Okay, you can touch it. Actually it is having inert gases like krypton and xenon. So they are going to plasma state and the charges are trying to go in all directions. When you touch it, you are a good conductor than air, so the charges are trying to come towards you.
And because of the sound, is it because there is high temperature plasma?
लाइट से दिस प्रॉपर.
हाँ, अंधेरे में.
लाइट ऑफ करने को बोल रहे हैं.
हाँ, जाओ ना, वो बीच वाला स्विचेस है ना, उधर डाउन कर देना. उधर है, लिखा है, वो पहला दो छोड़ के. क्या कर रहे हैं? जर शॉक आ जाता है उसमें, टक. नहीं, थोड़ा सा एल्यूमिनियम फॉइल है तो लेकर आओ, मैं बताऊंगा. वो तो रेडीमेड अमेजोन में मिलता है, उसमें क्या करना है?
उसमें ना हमने सबवे सर्फर किया
हाँ?
और फोन ऐसे रखा, पता नहीं कुछ हो गया फिर
हाँ?
हमने सबवे सर्फर चालू किया, फिर प्लाज्मा बॉल के पास से रखा तो चालू हो गया थोड़ी देर, एंड देन हैंग हो गया.
हाँ, हाँ, किसी को शॉक लगा दे. नहीं, येलो टी शर्ट वाला सबको पसंद है,
नहीं.
शॉक के लिए.
हाँ, यस,
वो सेलो टेप लेकर आओ. हाँ, इधर है, इधर है. नहीं, किसी को बकरा बना देंगे.
ये स्पाइडरमैन वाला हो गया.
वो स्पाइडरमैन नहीं, नागिन में होता है, नागिन 6 में है वो चुड़ैल वाली. वो सीरियल आती है नागिन 6 नागिन 8 बोल के, उसमें वो होती है ना ऐसा विच, ऐसा करने के लिए होता है ना ऐसे, यू नो इफ यू सी इन मूवीज दे विल शो समथिंग लाइक विच डूइंग दिस समथिंग, दे विल यूज प्लाज्मा ग्लो ओनली, देखने में अच्छा होता है। हाँ ऐसे ही। हाँ अभी
क्या लगता है इसे, शौक लगता है क्या?
हाँ
शौक लगता है इससे?
इसको चलो, उसको किसी को फ्यूचर चाहिए, इसको नज़दीक अगर टच कर लो।
ये क्या था? कुछ हो नहीं रहा है।
आप पूरा उसको दबा रहे यार,
तो क्या करना है?
उसको दबाना नहीं, जस्ट टच करना है टिप को। मगधीरा मूवी।
कुछ तो हुआ। अरे वो चिपक गया ऐसे, चिपक रहा है स्मोक किसमें आ रही?
जला रहे, किसी का जल रहे। यही वही क्यों दबा रहे?
सिर्फ टच कर रहा है।
इतना सेंसिटिव वाला है, आप इतना ऐसा डोंट डू, जस्ट टच इट। और कैन यू सी द आर्क?
ओह गर्म हो गया।
चलो चलो जाओ, चलो टैटू करना है, टच कर लो, टच बस
अगर नाम लगाएंगे तो फोन वाला
हो गया।
चल रहा है
ये ऐसे क्यों हो रहा है?
Because you are collecting all the charges at the tip, where the charges
इंसुलेटर है ना, ग्लोब
you are inducing outside, it is inducing.
ओके।
You are alternating current inside, so you are inducing it outside. It is a conductor, no aluminum. So you are inducing huge current in the small thing. Because that has lot of. If you take a wire, that is sheet, no, and at the tip, no, at the tip. उसको straight करो.
स्ट्रेट भाई चलेगा।
Sir, you were explaining something related to oxygen over here.
Basically, when we did these things, due to high voltages, oxygen go to ozone, and ozone is good also. I will show here. I have a beauty parlor gadget. Okay. Now let me stop these things. I have another experiment to tell you. Plasma has applications in various fields. So basically, this is a plasma application in beauty parlor. जो beauty parlor आंटी के लिए. This is a basically plasma for grooming. बालों में आग लगा. बाल नहीं आते. Actually, you know, these teenage में टेंशन की वजह से बहुत डैंड्रफ होता है, सब चीज होता है.
वो क्यों हो रहा था? वो फॉइल है जो क्या हो समझ नहीं आया।
डैंड्रफ, all these problems हो जाता है.
टेंशन से नहीं होता।
टेंशन से नहीं होते. डैंड्रफ ये सब चीज.
ये किसके ऊपर?
Can you see these things? Purple or bluish. This is basically argon plasma. There is a argon gas filled. Argon plasma. Basically, it is a high frequency plasma. So this high frequency, similar like ball. This high frequency plasma inside will couple with the oxygen and other air particles outside and transfer energy, and they become radicals.
Okay.
So radicals means free electron.
Free
having.
electron,
So
yes.
where they are energetic. So these energetics basically cells will try to.
क्या हुआ?
Your hair is good actually.
क्या हुआ?
No, let me tell you what happens. Nothing will happen as such. If the people have dandruff, no, let me tell you. तुझे है Quiz questions also. So there are 2 questions from each experiment. 20 MCQ questions are there. So just I will know how you understood the experiments. That is a part of just feedback. So and we have another feedback form also where we have some small questions. Please reply them. Okay. So we will distribute these things. Meantime, we will get ready for the other things. We will have this feedback form and question papers. Just give the feedback form. You keep the question paper with you. क्यों ले लिया? जैसे दूसरा उनका पेन ले लो. Give him pen. He want to write something. We will have a closing ceremony by certificate distribution and a vote of thanks. I invite our Dean, Dr. Mukherjee sir, Associate Dean Rajesh sir, our division head Dr. Nirav sir, our section head Manu sir, and Sunil sir, all please join in front of the screen. Please join us here. Actually, at the end, we have a small MCQ type because they are habituated for 4 option answering only. So we have 10 experiments, so 10 into 2, 20 questions we made. And we had a small feedback. We will go through this feedback later, okay? Before concluding, I want verbal feedback also from you. So if one or two wish to talk something, please come and say a few words. How you felt the program? Yes. That's what my first sentence. By the end of the camp, you should open your mouth. That is my wish.
Everyone come.
Yeah, then I will make everybody come and speak.
Let us make it everyone.
Okay.
Okay, let us do one.
Okay. First, let me start this. You think what you want to talk? You have already written in the feedback form. So by the time we will have certificate distribution. I request Dr. Mukherjee sir to please come and give away the certificates to the participants of the program. After that, actually after certificates, okay. After certificates, I want you to talk again. I kept that slot for you. I won't leave you. मैं पढ़ लूँगा उसके साथ सीक्वेंस में I will just go very quickly, please. I request, it is in the registration order, not in the any other order, how the registrations are done. I request Kapil Jamnapara to come and take his participant certificate. Yes. Yes, he will take certificate and hey, just hold it.
You tell one sentence. You tell one sentence about the school.
It was an amazing experience. Some things which were taught in our school, I did not believe them until I saw all of these experiments, and yes, it was very good.
Thank you, Kapil Kumar.
Aniket Singh to come. He is in class 11.
It was amazing and I like it very much, and if it happens next year I will come again.
I'm glad to have this opportunity to learn more about electricity and the electromagnetic effects. So it was a wonderful opportunity to have this and learn about.
It was a pretty good experience. The topic chosen here were also very good, capable for class 10 to 12th. Next year I will also commit to.
Experiments were really interactive and fun to do.
Thank you very much for giving us this amazing opportunity to learn science in a more fun and interactive way. Thank you very much for giving all your time. Thank you.
I really enjoyed this experiment, and I am surely going to come in next experiments and everything that you have done. Thank you for that.
This was a fun experience, and it brought with a very fresh outlook towards physics, and I really enjoyed it. Thank you very much.
Thank you so much, everyone, for giving this opportunity and also telling us each and every experiment with such patience. Thank you so much. Thank you.
Really, it was a nice experience, one which which were taught by our class teachers in theory. It was I have shown it. I mean, we have shown it. You all have demonstrated us this practically. But one thing I would like to mention that besides the experiments related to the electricity in future, means you should also demonstrate the activities of mechanics and if possible like laws of motion and and you can try for optics experiment also means. Thank you.
माइक देते समय ना ये ऊपर ही रखिए। अगली बार नीरव
It was quite a good experience, and the team was also supportive. Thank you so much.
Now we request Dr. Neeru and order. I request Janmejay Rajada of Dr. Pratipal Rajada, physics class.
It was a truly great experience. I loved the opportunity, and I will try to not miss this opportunity again next year. Thank you very much.
Good going.
I request M. Sita Mishra, daughter of Dr. Kishore Mishra, come and collect the in class.
So first of all, I'd like to thank all of our professors here. Now you all are professors for us, for guiding us so brilliantly through concepts we had never imagined we would feel up so close. We have always only learned from our textbook that, okay, electrons flow through this. Now there is a circuit, there is a device, it consumes this, and then it works like this. We had never thought about what magnitude of, like, what are the depth of the concepts in it, even the units. Gattu sir taught us about, like, how much is 1 ampere. For example, when we were told to estimate how much current will an electric lamp take. So we all were thinking 16 ampere, 20 ampere, and all that. Then we realized how big is 1 ampere, and a bulb only consumes 0.3 ampere. So like this, more experiments on more such complex topics or even simple topics are conducted in the future, it will be a great help to all those science students who want to deep dwell into the oceans of science. So thank you very much, and I really hope this is coming back next year. Thank you.
एक मिनट
First of all, thank you so much for allowing this golden opportunity to us. I'm very glad to perform these experiments while in trial standard. Thank you so much.
It was great and amazing. I learned a lot. Thank you so much.
शॉर्ट एंड स्वीट
So I really enjoyed the experience a lot. The specific thing I enjoyed about this experience was the practicals. It was the practicals they made us do, which is not done in our school or any other platform or in our tuitions they do. And it enhanced the theories they made us do. And thank you, the community who conducted this camp. Thank you.
एक मिनट
It was a wonderful experience and I learned a lot through this camp. I would definitely not miss this next year.
And last but not the least, let us invite Rishi Bhavsar, daughter of Chirag Bhavsar, and collect the certificate. She is in class 2 from Mangaldeep Vidyalaya.
Hi everyone, thank you for conducting this show. I like this so much and I learned a lot. Thank you.
Okay, thank you, sir, for giving the certificates. Now I request Dr. Mukherjee, sir, to please come once again and again motivate with his words for our young scientists.
Hello. Able to hear me? Okay, good evening to all of you. Good evening. I'm going to tell you something probably you know or you may not be knowing. Now, this was 2 days was all on electricity and magnetism. If I tell you, is there a relation between electric field and magnetic field? Is there a relation? And if there is a relation, what is that relation? propagate together. The relation. Relation is like something on the left side equal to something on the right. E by B equal to C. Okay. Anything more? This is field. Field is not energy. Energy will be in joules. Field will be volts per meter for electric in that unit. So, have you heard about something called as Faraday's law? Must have seen, must have done something. So, there were 4 laws, nearly more than 100 years back, there were 4 laws independent. One was if there is a charge, there is an electric field, discovered by Gauss, called as Gauss's law. Then people told magnets always have a north pole and south pole. Even if I take a magnet, break into 2, I'll have 1 north, 1 south, 1 north, 1 south. I can break it. Whatever you do, even at the smallest size, you'll always have north pole and south. So magnetic monopoles do not exist. You cannot tell I have a magnet which has only north. It will have. That was the second law. Then there was Faraday's law, which says that if there is a time varying magnetic field, you can get electric field. And fourth was Ampere's law, that if you have a current, you can generate magnetic. And all these were in your experiment. Then came a genius called Glenn Maxwell. Sorry, Glenn Maxwell. GH. So Glenn Maxwell, just in flow it went out. But who is Glenn Maxwell? So it's not Glenn Maxwell. So Maxwell came and Maxwell told that there has to be a relation, because he found that there is something called as capacitor. Now, you must have done some experiment where there is a capacitor. Has it ever come to your mind what flows from this plate of a capacitor to this plate? How does a current flow? It has not come. Nobody had a general idea. So Maxwell came with a concept and told that it is something called as a displacement current. And that we actually use in our circuits over there. So if I have a battery connected with a resistance and a capacitor, the capacitor we know will get charged. But at the time of charging, there is some current flowing in the circuit. Some current flows to resistance. What flows in between the capacitor is the displacement current. So it is physically not existing, but it is there. The moment displacement current concept came, you can find out that you can write all these 4 equations as one equation, and that is the electromagnetic field, and what you call as the electromagnetic wave, which is nothing but light. So electric and magnetic fields can generate something which is electromagnetic wave. It may be various frequencies or wavelengths, and this is the electromagnetic field which is called as light. Now, there are 2 constants in this. One is, if I want to write down, it is called as epsilon naught. Another is mu naught. Have you heard these terms? But is there a relation between speed of light and these 2 terms? So what is that relation? If you do this calculation, it will give you the velocity of light in vacuum, not in a medium. But if it is in a medium mu naught, you will also have to multiply something with mu and epsilon depending on what kind of medium it is. I thought that I'll just share with you that Maxwell later on got the Nobel Prize for this. That his addition of one term, displacement current, actually makes everything possible, like your remote, your connectivity or your antenna getting signals from satellite. All that is because of that single term called as del D by del T, which is the displacement current, which actually came into it. I thought I'll share with you, so when you go home, you can read a little bit more about this to enrich your ideas on electricity and magnetism. Thank you.
Thank you, sir, for sharing some fundamentals of electricity once again. And now I request our Manu sir, please come and
Okay, so on behalf of IPR Outreach, I take this opportunity to thank you all our dignitaries who are here to actively participate, especially the students who have joined. And we were going through the remarks they have given. We are really not only delighted, we are filled with more enthusiasm to conduct such activities in future, near future, every year. And definitely, we are going to add few more interesting experiments, especially for those who have committed to join again next year. Thank you very much. Thank you all.
Please say some words on behalf of IPR staff and parents.
Hello. Yeah, this was nice actually. The first time IPR has arranged such science camp at IPR, and this outreach division, they got good response. Students got their individual feedback actually. They enjoyed this event a lot. They could learn a lot. They have hands-on. Actually, they have seen sophisticated items like multimeters, then oscilloscopes. And I hope that this is the first event that is organized for IPR rights. But for outsiders also, we can think of it. And we can increase the strength. This time, I think only 22 students, they attended this camp. But on large scale, we should conduct this camp. And not during holidays only, so during working days also. Thank you.
Yeah, I take the privilege of giving the vote of thanks for this program. I'm very much humbled to thank all our administration, starting with our division head, Dr. Nirav sir, Mukherjee sir and admin for security permissions and conducting the program, for visitor permissions, for very scrupulous food for the 6 times we had. We thank our canteen and admin for permitting the same. Also for other provisions for the experiments to be conducted. As the students requested, it is in pipeline that we will definitely add some more experiments to our kitty to just satisfy the theme. Because if I have one experiment electronics, one experiment optics, one experiment mechanics, one thermodynamics like that, so it is very difficult to get the gist or entire test. So that's why we kept a theme. So definitely we will include these things. We will have different themes like heat and thermodynamics, optics, mechanics, like that. Theme-based experiments. Definitely we will try to incorporate as many experiments which are usually covered in the syllabus and not generally demonstrated in the schools, either in theory classes and practical classes. So as sir suggested, so I take this privilege to invite IPR staff for the first alpha version of this camp. Basically, I don't know how the experiments can be conducted hands-on because never we have such programs. We only have exhibitions. We demonstrate mostly exhibits, but never we allow them to touch anything. So because we don't know how the experiments can be conducted, how much time they take. So this gave a lot of experience for us about the time scheduling and the executing of the experiments. So definitely we will extend these things to other schools, mostly in the starting, you know, the government or very underprivileged schools, they don't have such facilities. So our motto of the outreach division in conducting such camps is to make the students choose science stream and later on pursue some engineering and physics, and definitely I expect to contribute plasma physics or something allied technologies related to plasma and tokamaks. That is our ultimate goal. What I can say, it is our swardh hai hamara. So that is what we want them. So definitely we'll extend to lower standards also, because already you have chosen science in 11th and 12th. So not much to motivate you to choose science, but just these experiments will motivate to choose engineering fields rather than only one IT related field. So if you choose all other fields, then only you will enjoy the things. That's why we want to demonstrate based on these experiments on different physics topics. Definitely we'll scale down these experiments to 7th, 8th, 9th also, and we'll try to execute these camps. So in coming summer and in the coming days, we will definitely have more camps based on different topics and levels. So I will promise these things. And just at the end, I want to thanks mostly our entire division for Rahul Vishwakarma for almost his one-man show for me. So from live streaming, for everything. So for executing everything. And I have Narendra sir, definitely for audio, video things and opening ceremony things, all the things for posters, labels, for maintaining things. He's like our backbone, DOP, Department of Photography, Photography and Direction Department. Actually, we are in front screen, he's back screen actually. And I thank our Priyanka for helping us for anchoring in the opening ceremony. And mostly, let me thank my colleagues as a parents, not only as a parents, as colleagues, and my electronic division team, Pritesh, Abhijit, Saurav, Deepak, Akhilesh. Yesterday Akhilesh came, and Minsha, Saurav, all these people who joined, they are joined recently in the electronics group, but they wholeheartedly, what can I say, so they gave their weekend, Saturday and Sunday. They came and from morning, I did not expect they will spend almost all days. They also enjoyed actually. So it's like Sunil, Prakash sir, Jyoti, all these people have nicely. Without their help, I could not do these experiments because executing 20 students, it's very difficult for me. Thank you all for helping me. So definitely, since our intention is good, I think all the things fall in correct place. So I thank all the things whom I mentioned or whom I didn't mention. So thanks to all once again. Enjoy. Thank you. With this, I say this is the end of the program. Kindly join for high tea.